Welcome to day 6. Homework is page 31 and 32. We've got a warm-up. I would suggest drawing a picture and labeling what we know. From the things we have labeled, decide what is an equation we can set up and solve. And then once you solve for x, use that to find what we're looking for, AC and CD. So we're going to pause the video for 5 minutes for you to do that. Once you're done with the warm-up, you can also be taking your homework out, so you'll be ready to check those answers. All right, when we draw our picture, one of the sides AB is 2x plus 7. One of the ones that's not opposite it is 5x minus 6. And then it's kind of hard to label the diagonals, so I showed it in the blue and the green there and just underlined them. So those two sides we know are not going to be equal to each other, but in a rectangle the diagonals are congruent. So set those two diagonals equal to each other, solve, and you get x is 5. Sub in 5 to the AC expression, you get 39. Now CD was not directly given to us, but CD is the same length as AB, so sub the 5 into AB's expression to get 17. Moving over to the homework. All these originated as parallelograms, and then we had to decide based on the markings which more specific parallelogram we could call it. So A had a parallelogram with a right angle, the box there, so that's a rectangle. Based on alternate interior angles, we get that one is angle 3 is 8. Now once we know angle 3 is 18, we know that one next to it is 72 because of the right angle, which wasn't one we wanted to find. But how we can use that is because diagonals are congruent in a rectangle, all these segments are the same, so we really have isosceles triangles. So angle 1 would have to be 72. If you have 72 and take those away from 180, you get 36 for angle 2 right there. And then the angle 4 is an angle on a line with 36, so you get 144. Going over to B, because we have 4 congruent sides, that's going to be a rhombus. In a rhombus, we know diagonals bisect the angles, so that gives us that angle 4 has to be 59 as well. We also know that we have parallel opposite sides, so by our zigzag with alternate interior angles, angle 1 has to be 59. And then in a rhombus, the diagonals are perpendicular, so where they cross has to be right angles, that's why 2 and 3 are 90. C is a rhombus because it has those tick marks for the congruent sides again. By our zigzag with alternate interior, 68 for angle 3, because the diagonals bisect the angles, 68 for angle 2 as well. 4 has to be 90 because the diagonals are perpendicular, meaning this is 90 as well. And then if you take the 90 and the 68 away from 180, that leaves you with 22 for angle 1. For 2, we had to draw our picture. Both of them dealt with HJ and IK, which are the diagonals. In a rectangle, it implies diagonals congruent, so you're setting those equal to each other and solving. We get x is 7, and when you sub back in, you happen to get 7 also for the diagonals. In B, similar idea, you get 6 for x. When you sub back in, you get 25 each for the diagonals. So these ones are each a rhombus. So we get diagonals bisect the angles, diagonals perpendicular, and also our 4 sides congruent. But we're working with angles here mainly. So angle 1 and 2 have to be 90 because the diagonals are perpendicular. With our zigzag with alternate interior, 3 would have to be 29, and because diagonals bisect the angles, 4 would be 29 as well. For your area, there's really 4 triangles there. We've got right angles where they cross, so you have 9 and you have 16 essentially. So you have 1/2 9 times 16, and then just multiply it by 4 to get the area of that triangle. In B, 2 and 3 are 90 because the diagonals are perpendicular. Once you have 90 and 52, subtract those from 180 to get 38 here. Based on your zigzag with alternate interior, this would be 38, and then 4 would have to be 38 as well, because in a rhombus, the diagonals bisect the angles. Doing the same idea 4 triangles that are 13 by 10, we end up getting an area of 260 for the rhombus. Number 4, if the diagonals are perpendicular, this parallelogram must be a rhombus. But a rhombus is supposed to have all 4 sides congruent. So therefore, it is impossible for a parallelogram to have the dimensions and markings shown, because if you have that right angle where the diagonals cross, then all 4 of those sides should have been congruent. All right, we're going to be over on packet page 28. We are going to do some proofs today that have rectangle and rhombus. So keep in mind on our card, rectangle does not imply only 2 things. Rectangle implies all of the parallelogram things, as well as the 2 new things. So really a rectangle implies 7 different things. A rhombus does not only imply the 3 things on the card, it also implies all the parallelogram stuff as well. So a rhombus really implies 8 different things. So we'll start out, do our statements, reasons, and givens. So we just want to get these triangles congruent. The only given we have is the rectangle. So I'm going to start with the fact that rectangle implies opposite sides congruent. And we get that because rectangle has all the parallelogram properties. So that means we'll have 2 sets. We'll have AD being congruent to BC, and also AB being congruent to DC. I'll do 1 set of tick marks for one of them, 2 set of tick marks for the other one. Now we have a whole bunch of different directions we could go. I'm going to explain 3 different ways we could go with this. We could do rectangle implies right angle, and get angles A and C to be right angles, and then do right angle implies congruent angles. You could do parallel lines implies congruent alternate interior angles. Well, first we'd have to do rectangle implies opposite sides parallel, but then parallel lines implies congruent alternate interior angles to get some angles from the zigzags. Both those ways will be a little bit more work. The quickest way is we've just got a reflexive. So let's maybe do that because it'll be quickest. But either of the other 2 ways would be perfectly correct to do as well. So make sure you write property with reflexive. And we'll have dB congruent to dB. And we'll mark that with an X. And in each of those triangles, we have 3 sets of sides marked up. So we just have side, 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 congruent to side, side, side. And our statement is just what we wanted to prove. We're going to move over to question 4 next, over on the next page. And you can go ahead, do your statements, reasons, and givens. We have one set of angles congruent, so we'll want to mark those up in our picture. Angle FAB is this big angle here, and angle DCB is this big angle here. Our other given is a rhombus, which has 8 different things it implies, all the parallelogram things, and then the 3 new ones. And let's come up with a plan. We eventually want to get DE congruent to FE. Well, DE and FE are sides in those triangles. So our goal is to get the triangles congruent and then do congruent triangles implies congruent corresponding parts to get what we want to prove. Because we want those triangles congruent, we should be suspicious as to why they gave us those angles congruent. Those angles are more than the angle that is in the triangle there. So if we have too much of an angle, we're going to want to do subtraction postulate. The thing that we want to subtract off, though, is the angles in the rhombus. So we need to first get those angles in the rhombus congruent before we can do our subtraction postulate. So specifically in the rhombus, we want these 2 angles here. I'm going to label them angle 1 and 2. Remember, rhombus has all the parallelogram properties. So we're going to do rhombus implies opposite angles congruent. And that'll give us angle 1 congruent to angle 2. We can now do our subtraction postulate. We'll do our big angle FAB minus angle 1 is congruent to our other big angle DCB minus angle 2. And then we'll rename those. Now when we rename them, let's make life easier and we'll number them. So let's put little angle 3 and little angle 4 there. You could use 3 letters when you rename them. You could say FAE and DCE, but we can number them clearly, and so it'll be a little bit less writing. So this will end up giving us angle 3 congruent to angle 4. And I'm going to put 2 marks on each of those because we now have them congruent. And that just gave us an angle in our triangles. Well, another way the rhombus can help us is rhombus has 4 congruent sides. And EC and EA are both sides in the rhombus. So we'll do rhombus implies 4 congruent sides to give us EA congruent to EC. We'll mark that up in our picture with a tick mark, and that just gave us a side in our triangles. So we have a side and an angle. Another thing we can get is we have crisscrossing lines that make vertical angles in those triangles. So I'm going to call those angles 5 and 6. And we can do vertical angles implies congruent angles, with angle 5 congruent to angle 6. And I'll mark up angle 5 and angle 6 with 3 markings. So in our triangles, we have 2 angles, and the side that's connecting those 2 angles is marked up. So because of that, that makes it angle, side, angle. I'm going to name our first triangle AFE, congruent to triangle. A was our angle we got from the subtraction, so that's going to match with C in the other triangle. F is the angle that had no markings, so that will match with D, and then that finishes with E. And then to finish off, we've just got our congruent triangles, implies congruent corresponding parts. And that'll give us what we want to prove, that DE is congruent to FE. We're going to flip back to the previous page and look at proof number 2 next. And we're going to give you about 8 minutes to take this proof as far as you can go, and then we'll play the video and go through the rest of it. So we'll pause the video right now for 8 minutes, take proof 2 as far as you can go, and then we'll go over how to do that after that. All right, so from our givens, we have a couple rectangle things we'll use and the midpoint. Our goal is to get those triangles on the left and right congruent, so then we can do congruent triangles implies congruent corresponding parts. So at some point, you need to do rectangle implies opposite sides congruent to get that left and right side congruent. You've got to do midpoint implies 2 congruent segments to get the AM and MB congruent. And then rectangle implies right angle. To get A and B are right angles, followed by right angles implies congruent angles. My black in step 3, the green in step 4, and then the purple stuff. You could interchange the black, the green, and the purple in any order. We just need all 3 of those at some point. What order you chose to do those things was your choice. That gave us an angle between 2 sides, so we had side, angle, side. Make sure the D and the C are in the same spot, the A and the B are in the same spot, and then the M's. And then congruent triangles implies congruent corresponding parts. I'd like to finish the video with looking at one of your homework ones. So if you could flip to question 2 on the homework. On question 2, we eventually want to get angle FAB, which is right here, congruent to angle EDC, which is right there. So our goal is to get those 2 triangles that they are in congruent, and then do our congruent triangles implies congruent corresponding parts. So there's one of the triangles. Here's the other triangle. Because they overlap, I would suggest do draw all of those triangles separately off to the side. It'll make it easier to mark it up. And notice in the givens, they gave you BE congruent to CF. Well, notice BE and CF are too short to be a side in your triangle. If we are too short, then we're going to have to do addition postulate to get the full side. BE will have FE added to it. CF will have FE added to it. Because you're adding the exact same thing to both of those, we would need to do a reflexive property first with FE. So don't forget to do that reflexive first before you do your addition postulate, and then that'll help you get a set of sides in our triangles. That's it for this video. Any time left in the period, you can work on the homework. Have a great rest of your day.